a significant amount. I can't remember exactly, but I mean, enough that it was causing a bouncing effect through a couple regulators into a building across a set of railroad tracks.
Oh my God.
It was fluctuating that hard.
From the heartland of America, the gateway to the West, this is Engineering Tomorrow, the podcast, keeping you entertained and in the know on the latest commercial and industrial heating, cooling, and water treatment technologies.
Welcome to Engineering Tomorrow. I'm your host today, Brian Gomsky, in the beautiful St. Louis, Missouri. It is a warm summer day today, and I have the pleasure of having a few guests in the house. Eric Eiler from Midwest Machinery, Jeremiah Anderson, and Bob Stortz from Midwest Machinery are also here. If you guys wouldn't mind taking a few seconds and just introducing yourselves and tell our guests why you're on this podcast today and what we're talking about.
Today we're going to go over boiler tips. I'm Eric with Midwest Machinery Company. Been with the company about 7 years now, and I've learned a lot as the boiler industry has kind of changed. We've kind of started to try to bring as much tips and tricks as we can to the trade as well. So, and Bob and Jeremiah are definitely a crucial part of that, being in the field all the time.
Okay, Jeremiah, give a couple words on your background.
Well, I've been at Midwest for 3 years now and have really gotten in depth with the new boilers and the high efficiency boilers. And it is a different ball game than what it used to be, where you used to go flip a switch, turn it on, and leave it. So it has changed quite a bit.
Why don't we back up? We got a big range of people who listen to the podcast, people who are just graduating school, all the way to people who've been in the industry for 25 years. Let's start with the most basic question. What is a boiler?
Boiler is just a way to heat water up so that our appliances that deliver air to the space can have a heat source. So we're using a combustion chamber to heat up some water. We're going to send that hot water to a fan coil, and that fan coil is going to have air blown across it and get heated up so that the space can become warm.
If I wasn't going to use a boiler to heat my space, what are my other options?
Electric heat. So a lot of times, like VAV boxes will have an electric heater in there. So that's predominantly going to be your other source of heat, is some sort of electric heat, may it be in a VAV or a rooftop unit, or gas forced air.
And what's gas forced air for all those?
So that's just your normal furnace.
Okay.
So
in commercial, they do that as well?
Heat exchanger and blowing air across that, and rooftops will have that.
What is the benefit of using a boiler over other methods?
One, with a boiler, especially nowadays, efficiency is the biggest one. So with a boiler, we're using water. Water is always more efficient when we can use that as a heat transfer media than air. And now with our condensing applications, we actually are able to get more of the heat that we're expending. So the BTUs, as we burn the gas, we're able to reclaim more of those BTUs and put them into the water in a more efficient manner. So,
and it provides longer distances that you can go with the heat instead of having duct or something. So, duct to travel that heat, air across. You can use water, piping to go long distances.
Right. So you're saying that we can heat the hot water up, and it's easier to transfer hot water around than it is to transfer hot air around.
And you have, with the modern boilers, you have better control of being able to modulate the fire rate to the exact load.
Right. So we can use the heat longer rather than over a longer span of time throughout the shoulder months.
Or just what you need.
Right.
Forced gas or electric don't have modulation control, really.
Right. So all or nothing.
Correct.
Jeremiah mentioned that there have been a lot of changes over the last 10 years, maybe even longer, with boilers. Talk a little bit more about what's changed and what's going on in the industry right now.
Well, the biggest thing is efficiency. Our entire industry is just driving to have the most efficient products that we possibly can. ASHRAE is driving that. There's many ASHRAE standards out now that by a certain date, products are to meet a certain efficiency or they're no longer become compliant. So manufacturers are driving forward to get the most efficient products they possibly can. And in doing so, you are taking a product that, is fairly simple and adding a whole bunch of layers of complexity to it. So I'd say, from my standpoint, definitely if the efficiency is the biggest change in it. I mean, we went from, large cast iron boilers that you just put some gas and some fire to and they worked right. And now we're, varying the flow, we're varying the air. All of them have VFDs now put into them to handle that. Our combustion rates are constantly changing. Within the combustion changing, we also have now this larger span of temperatures that we can operate through because we have that modulation that we can have. So then as it gets warmer and colder outside, our air temperature or our air pressure changes. So it's the amount of oxygen in the air is different. So we have all of these variables now that we're trying to tweak and tune and adjust all on the go to get the most efficiency out of it. Along with that, the different applications that we put them in, we used to have, a variable primary or a primary secondary type application was the predominant piping arrangement. We now have variable primary, which is another drive towards efficiency. So I'd say,
Can you explain what variable primary and primary secondary are?
So primary secondary, there's essentially two loops. Your primary loop is going to be your boiler loop. It's going to be a constant flow. That's important for a lot of the older heat exchangers required a set flow for them to work properly. So we give the primary loop its own pump. That's where the boiler then takes that water, heats it up, and it gets sent out to a secondary loop, which then kind of pulls off of that. Can go either direction with that. But so we had two independent loops that are headed then together with the primary secondary. Variable primary, the main loop is going through all of your building components and then background and also through your boiler. So as your building components open up valves and close valves, the flow through the boiler then changes too. So it's a change in load that it sees directly at the boiler rather than through some, header piping.
You mentioned, a lot of changes we've seen in the last 10 years again. How does that affect installation and layout? I would think with all the new technology that it's going to be a lot more finicky in terms of the installation and layout. Is that true or false?
It definitely is true, and I'll let Jeremiah and Bob speak a little more on the installation side of things because they get to see the hurdles in the field. But I know the layout, the manufacturers, they'll give a list of don'ts in their O&Ms, but they don't give a good list of do's because they don't want to take the liability on. So the design build contractors and the design engineers kind of have to learn trial by fire on how do we navigate the things that they say don't do, but also, make sure that we're not falling into one that they didn't mention, but is still going to be a potential pitfall. So I know that from an installation or a design standpoint, it's become very difficult just from the lack of knowledge that's in our industry about this because it's kind of on the cutting edge. There's just not a lot of information available for it. As far as the installation side goes, kind of best tips and practices have changed, right?
Right. More on, say, your gas piping, and you've got to be more spot on with it. Gas piping size, the regulators you use, how far away the regulator is from the boiler.
The vent off the regulator.
Exactly. All makes a big difference on the high efficiency boilers going out now. Water pipe sizing, how much flow is actually going through the boiler, because when you're in a variable speed primary loop, you're slowing down the flow of water through the building and also through your boiler. So you've got to keep track of what is actually flowing through your boiler at all times, and do you have enough flow through the loops, bypasses, three-way valves, and that sort of
so
thing.
It's not only taking into account what we're doing in the boiler room, but making sure that there's things installed out in the field that allow correct operation as well.
It's a complete system now that you're going over.
It's got to be a challenge. I know the technology is coming out so quickly, and we're even still catching up with VRF and helping engineers understand those, that technology and how to lay that out. And now you've got to deal with boilers. I mean, who do you turn to make sure? You mentioned the manufacturers will tell you don't do this, but who can people turn to for the things that they should be doing?
That's kind of a tough question. So we are definitely making sure that we're becoming the boiler experts. So we are an avenue for that. I'd say the collective mind in this room right now is a great source of information for that. Absolutely, the reps are supposed to be the main source of information for that. We also have contact with the manufacturers who, they're not going to put it down in paper in the O&M that say, this is the right way to do it, but they have, nationwide, worldwide experience with that. So they kind of have experienced the best practices and some other potential pitfalls. So, yeah, we're going to be your source of information for that, and we want to be, because the moment we can help with the design is when we can, raise our hand at a potential red flag of something that's going in. So,
and with the new technology and all of it, sometimes it's trial and error. You find something that didn't work, change it to where it does work. So the next time you're in that situation,
right,
everything can go right and smoothly.
Right. Well, kind of like the controllers, like you were adjusting the other day at the PID,
right.
Trying to get the set points on a boiler, trying to get it so it meets set point rather than bounce up and down across them.
And controlling that firing rate is what it's
right.
doing with the variable flow going through it. So the boiler's got to catch up with that as well.
But so with that PID, we've got the controller comes set from the factory as kind of what, is the best standard, but we know through, trial and error that not all projects are the same. Not all installations are the same, due to unforeseen installation practices that what works on one job site doesn't work on another one. So
most mechanical contractors, thinking about installation and maintenance, do you think most mechanical contractors right now equipped for these boilers, or do you really still need to rely heavily on OEM service? Talk about that a little bit.
I think they're getting there.
Yeah.
With the high efficiency equipment, maintenance is a major part of it. As far as keeping everything clean, your burners clean, checking your combustion,
mm-hmm.
On a regular basis. Just because the more efficient the boiler is, the more
the less margin for error.
Yeah, exactly. Less margin for error. So cleanliness is.
Yeah, I'd say the good contractors are. I mean, their boiler maintenance, I feel like, hasn't significantly changed on what they have to do. But I know a lot of guys didn't used to do combustion analyzation on it, and now we have to make sure that that's done every time. So
exactly. And you used to be able to let the old ones go for, what do you say, Bob? Long time without really touching it.
Right.
Not saying that's how it should have been, but that's how most of the time
That's
it
an
went.
old atmospheric boiler that really was on off,
right,
and without modulation, and not a very sophisticated burner arrangement.
Yeah, as far as the controls go, I'm not sure. There's too many service contractors that out there can handle the specifics of each manufacturers, because everybody's slightly different on how they do things, and I think there's going to be a heavy reliance on the reps and the OEM guys,
at least for the initial setup.
Right.
Okay, what type of maintenance can you expect on a boiler after it's installed? Is this monthly, quarterly, yearly? Are we doing checks and cleaning, or?
Usually it's annual. You're going to be pulling the burner out, cleaning the burner, being very gentle with the burners. Now, a lot of the in-shot burners now have a mesh on them that cannot be dented, scratched, folded flat or anything like that. because that ruins them. That they're done after that. So you got to be real gentle with them. Clean them out like that. Check your heat chambers and stuff while you have that out. Igniters, going through those, checking those, amp draw, making sure everything is, it's doing, heating up the way it's supposed to, and it's firing off like it should. And that should be done every year.
Testing all your safeties.
Right. Go through and test the safety circuit. So,
how about a lifespan? How long can we expect a boiler to last out in the field these days?
So most of the heat exchanger warranties come, like with a 10-year warranty on them. So I kind of always anticipate that a warranty is a much shorter period than they would expect the product to actually last. So, I mean, I would say a 25-year-old boiler wouldn't be that unheard of. However, like I said, we're on the kind of the leading edge of this product. So, I mean, we haven't had a lot of the very variable primary systems out there in that scenario to know how long it will. But I mean, as far as heat exchangers, kind of the main portion of it, and like I said, most of them come with a 10-year warranty. So I wouldn't say it would be unheard of to have a 15, 20-year.
Most exchangers are stainless as well, so
right.
The degradation is not as significant as in the past with maybe copper tubes or something like that.
Right, yeah, because the water would aggressive on them. Right.
Tell me about some of the craziest things you've seen out in the field with boilers.
What was that? One of them that had it was an undersized vent on the gas regulator caused the gas to spike and bounce. I mean, the gauge is, it's supposed to be stable. So if it's at 10 pounds or whatever, it's right on the 10 mark. This one was fluctuating a significant amount. I can't remember exactly, but I mean, enough that it was causing a bouncing effect through a couple regulators into a building across a set of railroad tracks.
Oh my God.
It was fluctuating that hard. Every time the boiler would pulse because the regulator couldn't catch up, that pulsing effect could be seen in another building.
And an extremely high PSI gas pressure on that one.
There's like 20 pounds.
Yeah, which 20 pounds is like nearly unheard of when we're in a building. Normally it's stepped down before the building and it's, a few pounds rather than 20. So that was a pretty interesting one.
Can a boiler shoot a flame like a fireball?
I hope not.
Have you ever seen that?
I have not seen that.
No, the flame inside of them is actually, so like on our variable primary, water or fire tube boiler, the flame isn't actually that bright of a flame. That mesh that he was talking about is where most of the flame is contained at. So you don't see like a fiery, flame. You'll see the coloring of fire,
and you can get some pretty good noise out of it.
Yeah.
When it's not set up properly, you get the howling or you'll get the rumbling. And the howling, if it's not set up correctly, it can be pretty loud and pretty...
Or hard light off.
Yeah, hard light offs. Reminds me of
shake.
It reminds me of like a car backfiring almost.
Right. But I've never seen a flame shoot out of one.
Fingers crossed.
I never did.
Not yet. Still early. Are boilers ever retrofitted, or are they always you start the building and you made a decision on construction that we're going with the boiler? Can you go back into an existing building and add a boiler later? Is it just too much piping? And
you can go in and retrofit one. They do it all the time.
It's not so much retrofitting the boiler per se as much as maybe adding boilers to accommodate additional load that might be imposed on the facility.
How do we make this decision? Where do you start when you're evaluating, either a retrofit or even a brand new building? And I'm the end user. How do I determine what's going to be the best solution for me?
Depends. Are you efficiency minded or are you upfront cost minded?
Okay.
I mean, I see hot water doesn't get VE'd or value engineered out very often. It seems like they VE out the chilled water instead. But I mean, can you
A lot of times it's, what temperature you want.
That's what I was going to say.
Okay.
It's
Right.
really temperature. If you're going to be doing heat pumps, for example, your boiler temperature is going to be rather low. Then you have to have a condensing boiler that can handle that condensation. If you're running reheat and maybe the hot water's pretty hot, above 130 for the most of the time, then you may strategize on a little different boiler.
All right. Load too, amount of load required. I mean, if you can handle the reheat with an electric coil, that's going to be a cheaper cost than it would be to put a boiler in. So maybe then in that instance, they would look at, it's less expensive. But once again, you're looking at efficiencies then at that point. So
What else should we know today about boilers?
read the O&M.
Read the O&M.
Yeah, I've been doing it. I've been in this business for 18 years now. And, a while back, you never did pick up that O&M to see what was in it. And nowadays, you can almost find everything about that piece of equipment from an O&M. And it'll get you a better understanding of that piece of equipment, boiler, and kind of like Eric was saying earlier, the don'ts, and once you have the don'ts and the sequence of operation, you'll definitely have a better understanding of how the boiler really works.
Who are the big boiler players in terms of brands that are typically reliable?
Camus, Lochinvar, Airco, Fulton. I think RBI is a fairly decent one.
RBI.
They're not in the territory a lot, but Cleaver Brooks is a good one. Depends on your sizing where you're going to, but I mean, if you're looking, couple hundred thousand BTU up to a couple million, those are going to be your main players.
From what I'm hearing, it sounds like support is also almost half the equation when you're dealing with a boiler. Is that an accurate statement?
I'd say support is
Crucial.
90%. I mean, so of all of those manufacturers that I just named, they all make good products. I mean, it's the support that you get behind that product that's going to make the difference. I've had that conversation 100 times with contractors, and it's, not if there's a problem, it's when there's a problem, because things happen. It's a job site. It's constantly changing. There's, in the middle of it, the architect decides that they don't like the way something looks and needs to change it. So that changes all the rerouting of all of your piping and everything, changes the size of your gas lines and everything. So it's the support that you get after the fact that makes a big difference, because all the manufacturers are going to produce a quality piece of equipment.
With that said, folks, we are out of time, and we will look forward to seeing you next week. Do me a favor and subscribe to our podcast, share it on social media. Have a good one. Thank you.
You've been listening to Engineering Tomorrow, the podcast. For more insights and downloadable content, please visit our website at www.engineeringtomorrow.blog. Until next time, engineer for tomorrow, today.